Alright, so today in class we discuss additive versus multiplicative relationships. We wanted to figure out how can we determine when the relationship between two quantities is additive or multiplicative. So we started off by creating a foldable. It's really basic. But what's highlighted here is the term add in the word additive to help us to know that if we have an equation and it is adding, then it's going to be an additive relationship. And also we have multiplicative, and we highlight at the beginning of that word because it looks like multiply, or it kind of indicates multiply. And so when you have an equation that shows that multiplication, then it's going to be a multiplicative relationship. And so the definition that we have listed for both of these is the same, with the exception of the operation that it's talking about. So an additive relationship compares the independent and dependent quantities of a relationship using addition, whereas a multiplicative relationship compares the independent and dependent quantities of a relationship using multiplication. Now, although they're similar, their equations look slightly different. So let's start with the additive relationship. You'll notice that the format here is going to be y equals x plus a. A is going to be that constant number that each term increases by. But our y is representing the output value, or the dependent variable. The x is representing the input value, or the independent variable. And again, a, or what I have here for the box, would be the number that each term is increasing by. So this is what you're adding to the term each time when you find that relationship. So instead of looking at a table and saying, oh, the relationship is plus 7, you would use this equation and start showing y equals x plus 7 instead of just saying the rule, what we're used to, of plus 7. The same is true for multiplicative. This equation is slightly different. It looks like y equals a times x. Again, y is representing the output, but this time we have the number in front, so this coefficient is in front of the variable, and it represents the number that we multiply by in a rule or process. So when you see an equation and you say, oh, that relationship is times 2 or times 4, you would actually put that number here instead of writing times 4 or times 2. So we'll show it using y equals 2x or y equals 4x, which means we're multiplying by 2 or we're multiplying by 4. And again, the x is the input value here. So we're actually going to do the assignment that we did in class today to give you a better understanding of it. We're starting with pattern A. So we have two patterns here that we're going to work with, and we're going to compare and see if we can come up with the rule for each of these. Or excuse me, not the rule, but we can determine if it's multiplicative or additive. So let's start by looking at figure 1 and figure 2. You'll notice here that they give us an example of the description, 2 groups of 3 tiles, to show this model here. So if I were using that, figure 1 shows one group of 3 tiles. Okay. So this group here, and here is showing there's 1, 2 of those groups. If I were to continue on, figure 3 shows that there are 1, 2, 3 groups of 3 tiles. And if I were to draw figure 4 and 5, what would the next picture look like? What would the next figure look like? Continuing from these patterns here, I would have something that looks like this. 1, 2, 3. I would have 4 groups of 3. Okay, and that's showing 1, 2, 3, 4 groups. Okay, and figure 5 would have 5 groups. So using the description here, we should have 5 groups of 3 tiles. So 1, 2, 3, 4, 5. Okay, so looking at our picture, we can start to see what is happening from figure 1, and then looking at figure 2, figure 3, and figure 4. Hopefully you can start to kind of recognize the relationship or the pattern here. But I want to take you, one of the things that you can do when you have the figures, the figure number is also referred to as a term. So in this case, I'm going to make a really big X and Y table, input-output table, or independent-dependent variable table. The figure is going to be our X, or our input, and the Y, the actual model, will be the number of tiles here, is our dependent variable. So figure 1, you can put this as term 1, term 2, 3, 4, and 5. What I want you to look at is how many tiles are in each figure. In this figure, there are 3 tiles. In the second figure, there are 6 tiles. In the third figure, there are 9, and then 12, and finally 15. So if I'm looking at this question here, it says, is the relationship between the figure number and the corresponding number of tiles additive or multiplicative? What that's asking is, what is the relationship between X and Y here? Okay. And if you said you're multiplying by 3 or times 3, that is true for each of these. This is times 3. So if I multiply the input times 3, the output is going to be that value. So whatever your figure number is times 3 is what you're going to get. Therefore, this is showing a multiplicative relationship. The reason why here, what we said about the times 3, each term, is multiplied by 3. You could also say each term increases by a group of 3. So each term increases by a group of 3. Now if we wanted to write an equation, I'm just going to bring my journal back here just to remind us. The equation for a multiplicative relationship should be in this format: y equals a times x. And instead of a, we're going to replace that with the number that we're saying. We're multiplying times, in our case, 3. So the equation here would be y equals 3x, or y equals 3 times x. Okay, again, this is showing a multiplicative relationship. Now let's look at pattern B. This pattern starts with a verbal description. It says there's 1 tile and a group of 3 tiles. So if I follow that sequence, figure 2 here has 2 tiles and a group of 3. Okay. So 2 tiles and a group of 3 tiles. If I were to build the next figure following this along, I would have that group of 3, and then I would have 3 tiles. I'm going to shade this one as well. Let's build figure 5. 3 tiles and then across. This fourth one has 4 tiles and a group of 3. And so this last one would have 5 tiles, 1, 2, 3, 4, 5, and a group of 3. Now, when you're looking at these and you start to consider what type of relationship this is, I want you to be careful that you don't just say, oh, well, it's adding 1 tile, because our picture is changing. Our figures are changing here because it is adding 1 tile. But if we actually made this into an X and Y, an input-output table, and use this information, how would that be different? Okay, so I'm going to just get the verbal descriptions here. We have 4 tiles and a group of 3 tiles. The final one is 5 tiles and a group of 3 tiles. Okay, so before we answer this question, if this is a multiplicative or additive relationship, let's break this into our X and Y table. Okay, again, X is representing the term number, and Y is actually representing the number of tiles in the figure. So here we have 4 tiles, 5 tiles, 6 tiles, 7 tiles, and 8 tiles. So now when I'm looking at the relationship between the figure number and the corresponding number of tiles, is this additive or multiplicative? And this is where you'll start to see that I get from a 1 to a 4 by adding 3. Now I could initially think times 4, but is that true here? 2 times 4 is not 8. However, 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7. And then 5 plus 3 is 8. Therefore, this is an additive relationship. It's an additive relationship because each group not each group, each figure shows 1 group of 3 being added to the other tiles. Okay. So you could use, or you could see patterns, and you'll be asked to extend the pattern and then to determine if it's multiplicative or additive. But like our notes started yesterday when we talked about independent and dependent, you could also have a table and a graph. Now I'm going to show you a table. Actually, go ahead and kind of show you what they're doing, then I'm going to switch it over so that you can see a completed table. We have the X and Y values, which are independent and dependent variables, but we also have a rule already here. So just looking at the rule, you should be able to distinguish, is this additive or multiplicative. Okay, and this is an additive relationship because we're adding 2 5/10 each time. So for this one here, it's showing us the process or the rule here. So it's almost like a workspace. We're going to substitute x for the input value, and that's going to give us our output value. So I have x, instead of x, I'm going to put 0 plus 2 5/10, which equals 5/10. 1 plus 2 5/10, which equals 3 5/10. And then we have 2 5/10 plus 2 5/10, which equals 5. Now you'll notice here that they actually gave us an output value, and now we have to work backwards to determine what would this input value be. And so you have to ask yourself, if I have 7 5/10, if I'm showing that I add 2 5/10 to a number to get that, the inverse of this would be true as well. So 7 5/10 minus 2 5/10 would give us our input value of 5. Okay, and we can show that here. And going across, that is a true statement. So to graph these are like ordered pairs now. The first ordered pair would be 0 and 2 5/10. The second one is 1 and 3 5/10. And then the third one is 2 5/10 and 5. And we'll put that fourth one on there as well, 5 and 7 5/10. So always start at the origin, which is 0, 0. We're going to do the x and then the y. Remember, this is independent, this is dependent. So starting at 0, 0, I'm going to go 0 and then 2 1/2 or 2 5/10 is there. We have 1 and then 3 1/2, 2 1/2, and we're going to go up to the 5. And then finally we have 5 and 7 1/2, which is right here. Now if I were to connect these dots, and I'm going to try to make it through them, just see that it's going to make a straight line. So this is showing a linear relationship. Okay, linear relationship, you can see that if when I'm connecting these dots it forms a straight line, that means it is a linear relationship. Let's take a look at the second one. This time we have this rule, and because we're multiplying here, this is a multiplicative relationship. Okay. And again, we can substitute for the x all of our input values, and then for this one we'll work backwards. So we have 2.5 or 2 5/10 times 0, which is 0. 2 5/10 times 1, which is 2 5/10. 2 5/10 times 2 5/10, which is going to give us 6 25/100. Okay, you just have to do some math out to the side. If you're not sure, just set it up, and then you can multiply. And then the last one here, we have 7 5/10, and we're going to divide by 2 5/10 to figure out what is the next input value here. So I could set that up right here and divide it by 2 5/10. And when you do that, you'll see that the output value, or the input value, excuse me, would be 2 5/10 times 3. So we found out it's going to be 3. Move that decimal. It's a whole number here. We're going to plot those points. And we'll start here. So our ordered pairs are going to be 0, 0, 1 and 2 and 5/10, 2.5 and 6 and 25/100s, or sorry, 2 and 5/10, and then 6 and 25/100s. And the last one we're going to put is 3 and 7 and 5/10. Okay, so let's go ahead. We're going to start at the origin again. Remember 0, 0. And then we're going to go 1, and we have 2 and 5/10. Then we have 2 and 5/10, and we're going to go up to 6 and 25/100s here. And the last one we're going to plot is 3 and then 7 and 5/10. Now again, these, if I connected these dots, it's also going to form a straight line, right? This is a straight line. This is a straight line here, which tells me this is also a linear relationship. But if I look at the two graphs, there's one significant difference. Can you see it? Yep, has to do with the origin. If you look here, this is multiplicative, and a multiplicative relationship will go through the origin. Okay, this is linear. This is an additive relationship, and it does not go through the origin. All right. So that should give you a better understanding of the difference between multiplicative and additive relationships. We can see them in a table. We could see them on ordered pairs. We can see them in a graph. You can also see them when you're looking at different patterns and trying to figure out, if I extended the pattern, what would that be? Okay. All right.